Okay, we're going to go over Pythagoras again. We reviewed it yesterday, but now we're going to deal with Pythagoras in 3 dimensions. So you sort of have to visualize. Who here does art? Anyone? You're going to be slightly advantaged by this because you can visualize a bit better than people that, can only see in 2 dimensions. So Pythagoras, what I taught you yesterday, applies to a flat 2D triangle. But if you're applying Pythagoras in 3D, you must visualize where the 2D right-angled triangle sits in 3D space so you can find the info you need about that triangle. So in your case, what does this mean? This often means you need to apply Pythagoras multiple times over, as in the example below. So we're getting straight into the example. Why? You got Pythagoras' formula yesterday. I have a cubic box. The sides are 20 by 20 by 20. What would be the longest rod you can fit into the box? Can I give you some time to get that example down? Make the picture kind of big so you've got space to add stuff to it. And you tell me, how would the rod sit in the box to get the longest possible? Let them mark. You've seen, my guys, last year you've seen this. Okay. A cubic box, sides 20 by 20 by 20. What would be the longest rod you can fit into that box? So I've tried to draw that in 3D. Is anyone game to draw a line where you think the longest rod is going to sit in that cube? Yes? No? Yeah. You draw a straight line, or try to draw a straight line.
It's not going to be straight. Try my best.
So he's tried to draw from the back left corner to the front.
No, I got rid of it. Don't worry, I got you still.
Did you actually? Because I'm going to have to mute that out now. That's fine. I'll fix that up. So I agree. Oh, she switched to the eraser. That's fine. That line there, or it could be that line there going across. Do you agree that that's all wonky? It's not straight up and down. Let me prove it to you as well. I made the box. There it is. That's the 20 by 20. Okay. This is this triangle here. 20 up, 20 across. The longest is not going to be along the bottom here. That's 20. So we made a right angle triangle here. Do you agree that that's a little longer than the sides? Okay. But if we also thought in 3D, and I got this one here, so it's even longer and a bit more wonkier. Okay. Versus this one. See how the second one here is a little longer? How does that fit? That fits in the back corner, going to the front corner. You see how you have to think in more 3 dimensions than just one flat plane? So today, we're practicing doing that. All right, and let's see, I'll get a ruler out and see if our maths matches with reality, real life. So, I'm going to neaten up that drawing. We're going to do, I need to know this. I need to know the fat red line. I need to know that. Where is the right angled triangle? Where is the flat right angled triangle there? Any ideas? Do you agree that this back side is part of the triangle? Where's the bottom of that triangle? Along the bottom here? Do you agree? If I had the photo, you could see it. It's along the bottom there. How do I find that though? I'll do another triangle in purple. Do I have 20 along that side? Do I have 20 along that side? Is this bottom red line, is that the hypotenuse of that triangle? See, I have to do multiple Pythagoras's to get the answer I want. So we're going to do purple triangle. 20 squared plus 20 squared is equal to, let's call this X, and let's call the fat red line that I want Y. 20 squared plus 20 squared, that is 400 plus 400. And so X squared is going to be 800. Opposite of squaring something. Square root, so X is going to be 800 square root 28.28. We just used Pythagoras to work out that X is 28.28 centimeters. Is X the... so I'll stop to give you time to get that down. While you're writing, we've already shown X is not the longest rod. It's longer, but it's not the longest. How do we find the red triangle? So, yeah, it's quite complicated. I do think that if you are visually able to visualize stuff, maybe into gaming and everything, you can see that. If you're not so much into that spatial recognition things.
So is the 28.28, is that the...
That 28.28, I'll do it in... 28.28 is this
Oh, yeah, it's just that one.
in green, yeah?
Okay.
Why do we need that? Because we need to know what the bottom of that red triangle is. And so your last working out is going to be 28.28 squared plus. Do we know how tall that back side of the box is? Is 20. 20 squared equals, I don't know what 28.28 squared is off the top of my head. That's ridiculous. 28.28 squared plus 20 squared is 400. Uh, 1199.76 to 2 dp. Y squared is equal to 1199.76. Y is going to be square root of that. 34.64 centimeters. My little assistant here, you. Can you please confirm to the audience what is the length, width, depth of this using that ruler? $20?
Yeah.
Is it? Can you confirm that for the people?
Yeah.
What did we work out the X to be? 28.28. This is this. What's the bottom? It's along the bottom of the cube. Is it close to 28.28?
Yeah.
Yep. And then this is the longest rod. This is Y. What did we work it out to be? 34.64.
Yep.
No reason to hide anything there.